Assalamu alaikum guys. Today I want to share you a short video of test and power supply that I just designed using the off-the-shelf buck converter, and it is a very compact design. As you can see, the size of the this box is only around 110 millimeter to 85 millimeter, which is a very compact design. And however, it is a 600 watt variable output test bench switching power supply using the off-the-shelf buck converter, and it can take input voltage up to 75 volt, I think so. And output voltage can be varied from 2.5 volt to 50 volt, and up to 25 ampere. However, with the condition that the output voltage or the input voltage doesn't exceed 600 watt. So let me introduce the different connectors. This is the variable 10-ton multi-ton potentiometer, which adjusts the output voltage very accurately due to its multi-ton capability. And then here are two connectors. One is the normal DC jack, which takes the input voltage, fixed input voltage, if it is not much of a higher amperage rating, then I can connect to this DC jack, and this goes to the this on off switch, which controls the on off mechanism of the this switching power supply, test band power supply. And then this is a voltmeter and ampere meter, which indicates the output voltage and the current that it is drawing. And these are the banana connectors circuits from where I can take the output voltage 2.5 to 50 volt. And here is another connector. This is a high amperage connector. If I want to utilize the full 600 watt range of this compact test bench power supply, then I have to connect the switch DC power supply, fixed voltage DC power supply, for example 48 volt or 70 volt or 75 volt, whatever it is. And it is its input is connected to this connect jack, and it doesn't has any series switch just like this. So the full 600 watt can be utilized by connecting the connector on this jack, the jack on this connector. So this I purchased this box from project box from the Digilog Lahore, and from where I sometimes purchase the other components and the parts used in my lab. And however, its top lid was blank, and I had to create a slit on it where I could install the voltmeter. So I custom made the top lid, which is you are seeing at the moment in white color. And on I created this lid dimensions and the design in the Fusion 360 software. And I generated the STL file, and then I gave that STL file to the vendor who had the 3D printers, and he printed me the this top plate in the plastic material, good plastic material. And on this top plate there is engraved high-tech power, which is my sole proprietorship power electronics and electromagnetics lab name. And then there is written test bench power supply, and the third line there is written 2.5 volt to 50 volt, 25 ampere output. So this is the compact design of test bench power supply of 600 watt range. and on this side is a big hole with the metal net installed from inside, and here are also three big holes and the metal net installed from inside, so that no insect can go on the inner side. And on this side is the small fan of the shell bug converter, which takes the input airflow, and that air goes through the heatsink and cools down, and the hot air comes out of these three holes. So this is the cooling mechanism of this testing power supply. So let's me demonstrate. At the moment, I would demonstrate with the maximum input voltage of 27 volt that I will give to this DC jack. And however, if you want to use full output voltage range to, I mean, 2.5 volt 50 volt, then you have to connect 60 volt or 70 volt switching power supply, fixed switching power supply to this big connector. So just for a demo, I give around 27 volt input. So I connected the input 27 volt to this banana jack, and now I turn on the switch, and you can see there are some voltage that you are seeing at the moment uh, on this test power supply. At the moment, for example, you are seeing around 13.3 volt, and if I rotate it, then it is increasing, and it is still increasing, and around 24.7 volt it stops. And if I go on increasing the potentiometer, it doesn't increase because the input voltage is limited to 27 volt. So the property of the buck converter is that output voltage would be always lower than the input voltage. So at 24.7 volt it stops, and however, if I have the 70 volt or 60 volt input given to this connector, big connector, then it can output up to 50 volt full range. Now if I move it to the lower side, now you can see the voltage is decreasing, and it is still decreasing, and at the moment you are seeing the lower limit, which is a 2.5 volt, and the red color indicates the voltage, blue color indicates the current. As I did not connect any load to this output connector, so the current is at 0 ampere. So let me demonstrate by introducing a load as well. So this is a 2 ohm heavy duty load, which is only of 2 ohm. So this is a heavy duty load. So as an example, now I connect so let me connect this load. So the load is connected, and at the moment you are seeing around 1.5 ampere at the 2.5 volt. No, as I increase the voltage, because this is a Ohm's law that if you increase the voltage and the load is fixed, then the current would definitely increase. So at the moment you are seeing at 3.7 volt, 2.32 ampere, So at 5.2 volt 3.24 ampere, and at 6.5 volt 4 ampere, and at 8.9 volt it is around 5.4 ampere. And now I go on increasing, then at 11.4 volt it is 7 ampere. So let me increase up to say 12 volt. So uh, it is so it is around 7.4 ampere. At 12 volt it is 7.4 ampere. And you would be wondering that the this switch and the banana connector cannot support more than 5 ampere. So why 7 ampere? Because the input voltage is around 27 volt at the moment, so the input current would be lower than 7 ampere, and even lower than 5 ampere, so this switch would not burn. So now you are seeing the load is also becoming reddish, and it is too much hot. So now I reduce the load, and so the current is decreasing. So this is the short demo with the load connected. uh, uh, Now let me show you the inside of this compact design of the shelf buck converter test by power supply. And now I turn off the switch. So I remove the jack. So this is the inside of this test bench variable output power supply. Here you can see the potentiometer, and here are the two DC jacks. This is a switch, and this is a buck converter. And on this side is a fan to cool the transistors and diodes using this big heatsink. And these are the outlets and inlet for the airflow with the metal net installed from inside. So as you can see, this is a very compact design. And however, there is one limitation that I had with the voltmeter, that this voltmeter without any external shunt can only show up to 10 ampere. So if I want to output more than 10 ampere, then definitely the output would be more than 10 ampere, but the output current indication would be limited up to 10 ampere. So at the 10 ampere it would saturate, the meter would saturate, and however the current would increase on this output connectors. So there would be no problem in the output current. So this is a very compact design and a very good design, with the only limitation that it has only voltage control. There is no current control with this buck converter that I had available at the moment. So otherwise it is a very good and compact switching power supply. And sometimes you should have such compact power supplies in your lab, so that you can test other modules and products while designing them. So guys, this is today's short video. So I hope you enjoyed this compact design of the test bench power supply. So stay connected, and thank you very much.